Welcome to this online learning course of earthquake engineering. The topic is dynamics. In this lecture, I will discuss dynamics about earthquake and plate tectonics. What are dynamic loads? There are two types of forces/loads that may act on structures, namely static and dynamic forces. There are two types of loads, static and dynamic loads. First one, static loads or static forces are those that are gradually applied and remain in place for longer duration of time. In other words, they do not depend on time. Okay, they are less dependent on time. These forces are either not dependent on time or have less dependence on time. For example, static forces and static loads that are dead load or self weight of the structure. Further, live load acting on structure is also considered as a static load because it usually varies gradually in magnitude and position. For example, furniture loading and library stack or even the person movement is also considered in a static load because their position and their magnitude are very much less change. Okay, not variation is so small, so that's why considered as static load. Dynamic forces. Dynamic forces are those that are very much time dependent, and these either act for small interval of time or quickly change in magnitude or direction. For example, dynamic forces, the example is earthquake. Here you can see as the time is moving, there is very much change in magnitude, even a very small interval of time. Okay, you can see the dynamic forces examples: earthquake forces, machinery vibrations, machine vibrations, and blast loading are examples of dynamic forces. In all the dynamic forces, they are time dependent. Structural response. What is structural response? Is the deformation behavior of a structure associated with a particular loading. For example, here for a particular loading, here is earthquake. The earthquake definitely behave in some manner. Okay, so the structural response associated with earthquake here, and the structural response with respect to wind here. Okay, and definitely for each type of loading this will vary. For static loading, the structural behavior or structural response will be different, and for dynamic, that will be different. So here is a structural dynamic response. Similarly, dynamic response is the deformation pattern related with application of dynamic forces. Definitely the dynamic response will be under the dynamic forces. In case of dynamic load, response of structure is also time dependent and hence varies with time. Okay, for example, here as here is a broad picture of earthquake. When the earthquake loading here, the magnitude is small, then the structural response will also small. As the time is increasing, the magnitude is increasing, then the structural behavior or response will also be amplified or have the higher value of deformations. So in case of dynamic load, response of structure is also time dependent and hence varies with time. Means the response will also time dependent and it will have different magnitude of deformation. Dynamic response is usually measured in terms of deformations, and deformations are displacement, rotations, velocity, and accelerations. Dynamic force. Dynamic force is defined as a force that changes in magnitude, direction in much lesser time of interval, or it has a continuous variation with time. Here you can see as the time is changing, their magnitude, their values are changing. This is example of dynamic force. Okay, there may be regular pattern or irregular pattern, but definitely the magnitude and direction in very much smaller time that will change. Impact load. Impact load is the other extreme where the load is applied only for an infinitesimal interval, mean very small interval of time with some momentum, and considered separate from the dynamic loads. This is also the separate category. In that there is only one change in time. Okay, I will show in the next slides the impact load. The variation of dynamic force with time is called history of loading. Mean any earthquake record or machinery record, vibration record. So all types of these types of loading are called history of loading. The variation of dynamic force with time is called history of loading. Prescribed dynamic loading is regularly varying loading in which well-defined cycles of loading are repeated equal interval of time. Okay, example of prescribed loading is a regular vibration of machinery with certain amplitude and frequency. Let me show the example here. Here is a sinusoidal wave, okay, that will continue after equal interval of time, okay, with same magnitude here. That is the example of machinery loading. Okay, that is a example of prescribed loading is the regular vibration of machinery with a certain amplitude and frequency. Okay, this is another prescribed loading here. Step type loading, typical step every equal interval of time step will keep on changing, but with equal magnitude. Okay, similarly here this is complex loading, but still after equal interval of time it is repeating. That is a prescribed loading. Types of prescribed loading: sinusoidal loading, step loading, complex variation loading. Okay, what is amplitude and frequency? Amplitude of vibration is the maximum structural displacement during one complete cycle. Okay, here is a one complete cycle. The maximum amplitude, okay, the maximum amplitude in a cycle, the maximum displacement or the value, the max of vibration is the maximum structural displacement during one complete cycle of load. Okay, frequency is the number of loading cycles in unit time, means how many number of cycles passes in 1 second. Means for any rotational motion or uh, any waves of waters, okay, in 1 second the number of cycle passing through a point is called the frequency. Okay, these are basic definitions. Now here are non-periodic loading. Here is a typical impulsive loading, or you can also say the blast loading here, the bigger impact. Okay, and non-periodic loading, that is a typical earthquake loading here, earthquake record loading. Earthquakes. An earthquake is the vibration of earth produced by rapid release of energy from within itself. Means earthquake is the vibration of earth. How it is produced? By rapid release of energy from within itself. This extra energy may be stored in earth and released at interval due to many different phenomena, some of which are common. Plate tectonics, means when the plate moves, then there will be earthquake, volcanic eruptions, lava eruptions, atomic explosions, and collision of massive meteoroids with the surface of earth. When from the sky they fall on the earth, then there will be lot of energy in the meteoroids, and in that result earthquake can also produce, may produce. Plate tectonics. In the plate tectonics theory, okay, crust, here is the section of the earth. Okay, here is the earth, and the section of earth is shown here. Here is the different layers of earth. Okay, crust, upper mantle, lower mantle, outer core, inner core. Okay, and okay, crust is the, here is the crust. What are the properties? Crust is the outermost layer of the earth consisting of solid material varying in temperature from surface temperature to maximum temperature of 1000 degree. Means from surface of earth to the downward, its temperature varies from 0 to 1000 degree. Its thickness under deep oceans is between 4 to 6 kilometer, and thickness under continents is approximately 30 to 40 kilometer. Here is a continents, here is a sea. Under the sea the thickness is low, and under the earth continents the thickness is more. Okay, next is mantle. This layer has an approximate thickness of 3000 km and consists of semi-solid to plastic material. The temperature ranges from 1000 to 3500 degrees centigrade. Okay, from this layer to this layer, mantle. Outer core. Okay, about this area, then inner core. Outer core is a thickness of approximately 2250 km and consists of a liquid at a temperature of 3500 to 4000 degrees centigrade. Inner core. The inner core has a radius of approximately 1200 km and is a layer of solid material at a temperature of higher than 4000 degrees centigrade. Now comes the main part of the plate tectonics. The outer layer of Earth, having a thickness of 100 km, is relatively rigid and is called lithosphere. Okay, the layer of Earth below lithosphere, having a thickness of 400 km, is softer and is called asthenosphere. For plate tectonics, these two terminologies are very important, because the upper crust part, in plate tectonics, that is lithosphere, which is the crust hard part of the Earth, that is 100 km, and after the below 100 km, the 400 km softer or molten part, that is the asthenosphere. Okay, the harder part moves on the molten part of asthenosphere. The lithosphere acts as a rigid plate that moves over partly molten asthenosphere. According to this theory, lithosphere is cracked in places or broken into smaller pieces or plates. This may have happened during initial drying of Earth from molten state. Okay, there are 7 large and several small plates. Okay, the largest plates are Pacific plate, the North American plate, the Eurasian plate, the Antarctic plate, the Indo-Australian plate, and the African plate. Okay, now plate boundaries. The plate boundaries, there are two main boundaries developed due to uh, uh, plates movement. First one is mid-ocean ridge and subduction zone. What is how these two boundaries develop? When two plates, this is the bigger picture, but shown on a small scale. For example, we take this left part, mid-ocean ridge. When two plates move apart, move away from each other, then due to molten lava, there is a comes out, and on the surface, after the hardening of the lava, their new boundary will develop. That is called mid-ocean ridge. Okay, this phenomena mostly happens in ocean, so that's why it's called mid-ocean ridge. Second one is subduction zone. Here, when the two plates are moving towards each other, then the one plate goes under and the other plates comes over the another plate. When the lower plate goes into the molten lava, that start melting, and after melting it start again going to become the part of the upper layer. So this region is called subduction zone. Okay, where the plate melts. Further, there are three types of plate boundaries depending upon the relative movement between the two adjoining plates. Okay, there are further three plate boundaries which are developed due to relative movement. Okay, convergent plate boundaries, divergent plate boundaries, and transform plate boundaries. Okay, here is a transform. There is a relative movement. Okay, one plate move downward, other move upward. Then due to that, there is a boundary developed, that is called transform plate boundary. Similarly, divergent plate boundary here, when the two plates start moving away, okay, molten comes out. So this is also the same example of mid-ocean ridge. This region this boundary is called divergent plate boundary. Convergent plate boundary, okay, when the two plates comes cross, okay, one plate goes down, and this region or this boundary is called convergent plate boundary. This is also example of subduction zone. Okay, here is a subduction zone. According to continental drift theory, all the continents were once part of huge landmass which have slowly moved apart. Mean after hardening, the parts start moving away. This is the history. The Indian subcontinent was not a part of Asia. It drifted over millions of years from Australia to Asia, and the collision produced Himalayas. Himalayas hills are produced due to the collision. Modern techniques such as GIS and GPS prove such movement of continents. Faults. Faults are cracks which are developed within the main plate. These are cracks developed on the plates, and this is also very important parameter because during construction of dams, buildings, we have to take care that isn't there any fault lines or not. So proper maps are present of faults. Here is a map of the Indian plate movement. Okay, evidence of plate motions. You can search this topic on the internet. Here is also reference. This is a optional for you. I have just given you an example of the Indian subcontinent. Okay, so that's all for today's lecture. Have a nice day.